So what is, again, let me remind you, what is the fundamental theorem of algebra? Fundamental theorem of algebra. Algebra. Seems pretty important. Fundamental theorem of algebra. And how are we going to use it? How are we going to use this fundamental theorem? What are we going to do with it? New set of notes. It's going to review what we did before, but we're gonna really talk about how do we use this fundamental theorem to solve some problems. So again, the fundamental theorem of algebra says that any polynomial, just a reminder, any polynomial of degree n, right, the exponent, has n complex roots. Complex roots. That's what we talked about. Our fundamental theorem says any polynomial of degree n has exactly n complex roots. Has exactly n complex roots. They match, right? The number of roots, right? And I say roots, I also mean things like, these are also other words we had were zeros or solutions, right? Talked about this last time, solutions. We had factors, all those things, right? So for example, if I have an equation like y equals 3x cubed minus 2x squared plus x minus 1, I know that there are exactly, for this problem, there are going to be exactly 3 roots, right? 3 roots for this problem because the degree of the equation was 3. It will have exactly 3 complex roots. 3 complex roots. But the complex roots come in 3 different flavors. These complex roots come in 3 different flavors. There are 3 kinds of roots. Let's go down here. 3 kinds of roots. Right, these complex roots come in 3 flavors. We can have what we call a real root, and we can have an imaginary root. Right? A real root is a root that actually touches the axis. That's a bad drawing. Let me try this again. A real root is one that actually touches the line, like right here. This is a real root. Touches the x-axis. Touches the x-axis. An imaginary root is like here, where it does not. Does not touch the x-axis. It's imaginary, it's like floating in space, this imaginary root. And even with the real roots, there were 2 different kinds, right? There was rational and there were irrational. So these were like the 3 flavors of roots, right? There's rational, irrational, and imaginary. So we have these 3 different types of roots you can have: rational, irrational, or imaginary. And we know that the total, if I add up how many rational roots this equation has, how many irrational roots, and how many imaginary, the total number of all of these 3 together has to equal my degree, has to equal 3. The total number of roots has to be equal to the degree. Okay? That's what we talked about last time. Total number of all these, total of all 3 Total of all three must equal the degree. Right? All of these are all kinds of complex roots. All of these are fall into the complex root category. Right? They're all complex roots, but there are three different kinds of complex roots. There's rational roots, there's irrational real roots, and there's imaginary roots. These three kinds have to total the number of the degree of the equation. Okay? And there was one more rule we talked about last time. The irrational and the imaginary, the irrational root and the imaginary root, one of the rules, I'm not doing a good job of organizing this. Hold on, everyone. Let me see. Let me do something like this. Erase this. Because what I want to show you is that the irrational and the imaginary both have a rule where they come in pairs. So the irrational and the imaginary, these must come in pairs. For example, plus or minus square root of 3 for an irrational root. That's an example of one that would be irrational. Irrational. Or plus or minus 2i, right? We have one positive, we have one negative. They come in pairs because they have this positive version and this negative version, right? Irrational could be plus or minus square root of 3. Imaginary could be plus or minus 2i. And the reason why is because of the quadratic formula. Who remembers our quadratic formula? Way back in Algebra 2 or Algebra 1, everybody's favorite quadratic formula. Anybody remember the song? Anyone make you sing the song for the quadratic formula? Da 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 da. No? Who thinks they can remember the quadratic formula? Not a lot of people. All right, let me sing this song for you, everyone. Get you a little song for you. Quadratic formula is how you solve quadratic equations. So the song here goes like this. X is equal to negative b plus or minus square root b squared minus 4ac, everyone's favorite part, all over 2a. There you go, everybody. There's a quadratic formula. And what this quadratic formula does is it finds zeros. This finds roots. Right? Oh no, yeah, bad memories. But because this quadratic formula finds roots, this plus or minus is why there are 2 for the irrational or the imaginary. This plus or minus is why there's these pairs that happen. Because this quadratic formula, the irrational and the imaginary have to, because that's where the square root, right? The square root is what causes our irrational roots, and the square root is what causes our imaginary roots. The square root causes all these troubles. So that's why these are in pairs, because of this plus and minus. The one is a plus, one's a minus. We have this two-sided thing. So these come in pairs. And so what we can do, because we know all these rules, we can create a chart of possible roots. Where we're going to say, and this is how we're going to solve, how we're going to use this fundamental theorem of algebra. So we're going to say our chart, we have the real side, and we have the imaginary side. And on the real side, we have rational, and we have irrational. So we have these 3 sort of possibilities. We're going to create a chart of possible roots, and the number, the sum of all these sections has to be equal to complex roots, or the degree of the problem over here has to equal in our case. So our question was this equation up here, this 3x cubed minus 2x squared equation, right? So I want to make a chart of the possible situations that that equation can fall into, right? So I have y equals 3x cubed minus 2x squared plus x, what did I say? Plus x minus 1. So I want to think of all the different possibilities. How many different possibilities are there for ways that I can have roots, like the different numbers of roots I can have for this possible situation here. This cube equation, right? My degree is 3. So my total roots has to be equal to 3 total roots. 3. And what are my possibilities? The first easiest possibility is that all of my roots are rational roots. They're all normal, nothing weird. All 3 could be regular rational roots. I could have like a 2, a 1, a 7, negative 1/2, whatever. All rational. And no irrational and no imaginary. That's one possibility. Okay. That would look like 1, 2, 3. I have all the numbers here, all the roots, and all the roots touching, right, all real roots touching all real numbers. That's one possibility. What other possibilities can I have? What if I have only, what if only, is it possible to only have 2 rational roots? Is that possible? Can I only have, instead of 3, maybe let's try 2. If I have 2 rational roots, how many roots do I have left over? They have to equal 3. I need a total of 3 roots. So if I use 2 in the rational section, has to equal 3. If I use 2 in the rational section, that means I have 1 left over to put either here or here. But am I allowed to put 1 root in the irrational or 1 root in the imaginary? Am I allowed to put 1 root in here? No, I'm not. Thank you, Naomi. I'm not allowed to put 1 root in here. So that means that in no universe can I have 2 rational roots. It's not possible. That's not a possible option. Because it doesn't work, it doesn't follow the rules. So the only other situation is, well, I have 1 here. Oh, wrong color. I have 1 here. And then I have 2 left over, and I can put them in either one. But can I have 1 there, and can I have maybe 1 irrational and 1 imaginary? Is that possible? Is that allowed? One of these, one of these, one of these. Split it fairly. Is that allowed? What do you think, everybody? Can I have 1 imaginary, 1 irrational? No, not allowed. Not allowed because these have to come in pairs. My irrational root and my imaginary roots must come in pairs. These 2 must be in, not be, I should say, must come in pairs. And I don't mean pairs like, oh, 1 of each. I mean pairs like together. Must come in pairs. I can only have 2 or 4 or 6 or 8. I can only use even numbers for my irrational and imaginary. So I could have 2 irrational, and that means I have no imaginary. And that's okay. That follows the rules. This is an option. What this one would look like is I have one that crosses at like, -5, and then 2 more that cross at some square root, like square root of 3 or negative square root of 3. 2 more that kind of cross at some weird radical number. That's what that one would look like. Here I have all regular numbers. -3, I got a 1, I got a 4. This is all regular numbers. But this one crosses at some crazy decimal place. Some crazy square roots. I have 1 rational and 2 are irrational. 2 are some square root number. It does cross. It does cross because they are real roots. Real roots means they do cross, but they cross at some weird decimal number. Some weird square root number. And that's what this one would look like. If I had one real rational root, like a 3 or whatever, and then 2 others that are some square root number. They come in pairs. Right? There's the pair. Another possibility is I have 1 rational, no irrational, and that means I have to have 2 imaginary. And again, that totals 1, 2, 3 roots in total. 3 complex roots in total. And what that would look like is I have 1 number that's rational, like my -3, and 2 more that don't touch. Right? 2 more that don't touch. That's what this one would look like if I was doing 2 imaginary roots, 2 imaginary roots, and 1 real root. Because my irrational and imaginary have to come in pairs, right? There's always a pair. My 2 square roots come in pairs, or my 2 imaginary roots, right? These here are imaginary. Like one of them is 2i and -2i. We can't see them because they don't cross the axis. They're imaginary. That's what it means. Imaginary means you don't touch the axis. So these are my 2 imaginary ones. Maybe one of them is 2i and the other is -2i. But they always come in pairs. Just like my irrational always come in pairs. Okay? So let me ask you, are there any other possible combinations I could have? Any other possible arrangements? Can I said we can't have 2 rational numbers, right? Can I have no rational numbers? If I have no rational roots, is that going to work? Maybe like, can I put all 3 in here and none in there? Is that okay? Is that allowed? I got 3 here. Now that's not allowed. I need to have, right? I can't have 3 here. I have to have 2 or 4 or 6, right? They have to come in pairs. If I have 3, there's one that doesn't have a pair. So this is not allowed. Not allowed. What about 0, 0, 3? Is that allowed? Same thing. Not allowed, right? Has to come in pairs. What about 0, 2, and like, oh, I got 1 there. Oh, no, that's not allowed. What about 0, 1, 2? Nope, that's not allowed. What about like, I don't know. Any other combinations I can do? I think that's it. 2, 1, 0. Nope, that's not allowed. 2, 0, 1. That's not allowed. I think these 3 are the only possible combinations I can have. These 3 are the only possible. Yes, and thank you, Jasmine. That's a good question. The rational ones, you can have any number of rational roots. There's no restrictions. Any amount allowed. Rational roots are not restricted in any way. You can have 1, 2, 3, 4, any number. You can have any number of rational roots. Only irrational and imaginary have to come in pairs. Rational can be anything. Okay? So these three are graph of this equation. This equation must fit into one of these three categories. It is guaranteed to have at least one rational root. One of them is going to be some regular number. And the other ones could be irrational, could be rational, could be imaginary. We don't know. But this graph is guaranteed to fit into one of these three categories. It has to. That's the rules. It has to have three roots. These are the only roots that are possible. And this is the only set of combinations that this graph can have. So it has to be one of these three. It's going to have one rational root, guaranteed at least one, and then some other situation. My question is, which one is the right one? Which one of these is the correct answer to this graph? Which one of these three actually fits with this graph? Which one's correct? That's the question. And to figure this out, well, there's a lot of ways we can, and this is the fundamental theorem of algebra. How do we figure this out? To figure this out, which one is right, which one is right, how do we know? We're going to do a graph. Graph on Desmos, and look. God, that's really, really bad writing, but graph on Desmos, and look. Graph on Desmos, and take a look. So let's pop on over to Desmos. Hold on, let me head over there. There we go, browser. So we're going to use the Desmos calculator. Let me just set that up, hold on. And we're going to, all right, here we are, Desmos calculator. My equation was y equals 3x cubed minus 2x squared plus x minus 1, right? All right, there we go, everybody. There we go. What have we got? What kind of situation is this equation here? Well, we have this little bump here, and we have only one spot where we're touching. Plus 2. No, doesn't matter. Minus x. There we go. This is going to be a little better. A little better visual. So here's my situation. I have one place where I'm crossing, and I have this little bump here that doesn't cross. So this number here is my one real root, and these other two, well, they don't cross. So this has to be in our chart example. Which one is the correct one? It has to be the one that has one real root. This has got to be some fraction. I don't know what the fraction is, but this is one real, and two have to be imaginary. So if we go back to our chart, the one that's going to be correct is this one here. This one is the one that's correct. My equation, this equation here, has one rational root and two imaginary roots because one crosses and two don't. And that's what you're going to be doing in your assignment. You're going to be figuring out what the chart is for your equation, graphing your equation, and telling me which of these three, which of the choices you have is the one that fits for that equation. Which choice is the correct one? Look at the graph, take a look at the graph, and see what the correct choice is. And that's going to be what your assignments are going to be, what you're going to be doing for your assignments. All right? Let's try another. Let's try another. So if I have another equation, let's say y equals x to the 4th power minus 2x to the 3rd power plus x minus 9. There's my equation. I want you to make a chart and determine which I don't know, which situation, which combination is correct, which combo is correct. Correct. So we're going to make our chart, and we're going to see the possibilities for this root. So we've got our real side, and we've got our imaginary side. Let me give myself a little bit more room here. Real side and our imaginary side. Break those apart. And then we've got our real side has also rational and irrational. Got those split up there. So this is our chart. What is the total number of roots that this chart has to equal? What is the degree of this equation? Degree is 4, right? So my degree is 4. So I have to figure out, I need to make all these numbers have to equal a total of 4. What does it say on top where here? Make a chart and determine which combo is correct. Make a chart and determine which combo is correct. And I know that the combinations have to equal a total of 4. So let's see what our options are. Let's see what the possibilities are. See if we can work this out. Easiest choice is all of them are rational. All 4 are rational. I have no imaginary and no irrational. And that's totally possible, right? I could have all 4 touching, or maybe I have a quadratic, what do I call it? A quad root, or a double root, like 2 double roots, whatever. We got a lot of possibilities. So all 4 could be rational. That's fine. Could I have 3 rationals? Is that possible? Could I have 3 here? So if I have 3, I mean, I'm allowed to have 3 rational roots. Rational numbers can be anything. But now how many do I have left over? I've only got 1 left over, and I need to put 1 root in either here or here. And that's not going to work. I cannot have 3 here because then my 1s are going to be left over. So I'm not, in no universe is there going to be 3 rational roots. It's not going to happen. Yeah, Jonathan, that's a great comment. One of the definite possibilities I can do is I can have none here. Oh, wrong color. I can have none here, 2 here, and 2 here. That's fine. That's allowed. What other combinations are allowed, folks? Enter in the chat. Type in the chat. What other combinations are we going to go for here? We can have 0, 2, 2. That's fine. What else? Enter some combinations in the chat, everybody. What do you think? Kermit says, ooh, 2, 2, 0. Yeah, for sure. 2, 2, 0 is great. That's a possible combination for sure. 2, 0, 2. Yeah, 2, 0, 2. Brian says 3, 1, 0. Is that allowed, folks? No, I can't have the 1 here. I cannot have singles in my irrational or imaginary. Have to be doubles. So that one's not allowed. What others? There's like 3 more. Other combinations, folks? What else? Hey, Edward, there we go. 0, 4, 0. All of them could be irrational. That's fine. I can have 4 there. That's totally allowed. Totally allowed to have 4 here. Because it's coming in pairs. I have 2 pairs. That's totally fine. 0, 4, 0. That one's allowed. Any others? Whoopsies. I think there's one more. One more, everybody. There you go, Jasmine. Exactly. 0, 0, and 4. All of them could be imaginary. That is also allowed. So those are my possibilities. These are all the possibilities for this graph. Now, you don't have to graph them over here, but just so showing you, if I had 4 rational and none others, then there's 4 places where it crosses. 1, 2, 3, 4, like that. 4th power has this kind of W shape. 2 irrational, 2 imaginary, that's going to be like 1 dip and then another one over here, right? 2 and 2, well, that's going to cross 4 times. Oopsies. Ooh, too many wiggles, everybody. 1, 2, 3, 4. 2 and 0, that's again going to be 2 and 0. And then all 4 irrational, that's still 4 real ones. All 4 imaginary, that's going to look like this. None of them touching. So which combination is correct? Which one of these is the correct one? X to the 4th minus 2x cubed plus x minus 9. I'm going to take this, graph it in Desmos. And let's go over to Desmos. x4 minus 2x cubed plus x minus 9. Okay, I'm going to try to remember that. And let's erase this. Get our next one. X to the 4th power minus 2x to the 3rd power. Oh, interesting. Starting to take shape. You see there? Plus x, interesting, minus 9. Okay, whoa. Interesting. So there is our situation. So I have 2 places where it crosses. Now let's look at these numbers. If I click here and click here, I see that these are decimal numbers. See, these are decimals. And I see that there's only 2 of them, and I have this little bump down here. And that means that my other roots, there's only 2 that are real, 2 are real, and the others have to be imaginary. Now you have to be a little bit of a detective here to figure something out. My question is, which category are we in? Which is the real category? So let me go back to our, I wish I could do both these at the same time, but let me go back here. So we know that it crosses only 2 times and 2 have to be imaginary. So already I can say it's not this one, not this one, not this one. Yeah, 2 real, 2 imaginary, exactly. But I don't know, is it, it's not this one, it's not that one, it's not that one. I don't know if it's going to be, if the 2 that I have, right, and it's not this one either, not all 4. So it's either this one or this one. My 2 reals are either going to be 2 irrational real or 2 rational numbers. How do I tell the difference between these 2 things? How do I tell the difference between an irrational root or a rational root? How do I know what these differences are? Let's go back to the graph. So here's our graph. are these numbers, how do I, whoa, what happened here? I don't know if that was everyone. Are these numbers rational numbers, or are they irrational numbers? And how do you tell? Well, let me give you a little clue. Irrational, to tell if a number is rational, means there is no pattern to the decimal. Irrational means it goes forever without repeating. So if the decimal has weird numbers, it's basically if it's a weird decimal, then you have an irrational root. If the decimal is weird, if it doesn't repeat itself, if there's no pattern you can sense, then it's going to be an irrational. A rational root, rational 0, rational, means if it's a regular number, regular number, like, 2 or -3 or 1/2, right? Some kind of regular number. We know it's rational. Or if the decimal repeats, like 1/3 is 0.333 repeating forever. So that's how you can tell if a decimal is an irrational decimal or a rational decimal. Basically, if it's some kind of normal pattern, if it's a normal pattern, it's going to be rational. If it's an abnormal pattern, it'll be irrational. So, taking a look at this situation here, do we think these two zeros are irrational, or do we think these two zeros are rational? Looking at the Desmos numbers, we have 1.447 and 2.447. What do we think? Do we think they're irrational, or do we think they're rational? Let's take a vote. Are they a regular number? Clearly they're not a regular number, it's a decimal. But is it a weird decimal, or is it a repeating decimal? 447, is that repeating, 447? Kind of looks like it's, if it was like 444, that would be repeating. But 447 is not really repeating. 447, right? I think probably we have some irrational roots. Based on how I see here, it's 44, but it's also a 7, right? It's not like a regular repeating decimal 333. If it was like 444, for example, 444, repeating forever, maybe that would be irrational. But I think we have ourselves two irrational roots. I think it's irrational. And as you look at these decimals more, you'll get a better picture. But again, I'm not going to mark you totally wrong on your homework. It's just a chance for you to practice. I think these are irrational. It's hard to tell exactly, but that's my best guess. Because it doesn't really repeat. It's not a clear number, right? Hard to tell exactly what these situations are. So if we go back to our process here. What am I looking for? Back to our situation. Whoa. Go here. Come on. There we go. I think the situation that we have is, I think we have irrational roots. I think we're here. And that's going to be my best guess. As long as I know I've canceled out the things that it's not. It might be rational, but I think probably it's irrational. Decimals don't seem to repeat. Seems to be pretty weird numbers. All right, what about one more? Let's try one more. Let's try, oh, wrong color. Y equals x squared minus 6x, whoa, minus 6x plus 9. Let's make our chart. Make it a little bit better. I did a real bad job. Make a chart. And figure out what categories we have. We have our real, our rational category, our irrational category, and we have our imaginary category. So we put our chart together, figure out what possible combinations we're going to have in this equation. So what is the total that my roots in this situation need to be? What's the degree of this equation? The degree of my equation is 2, so that means my total has to be equal to 2. I have to have 2 roots in total. All my roots have to total 2. So what possibilities do I have, everybody? List in the chat, what are my possibilities? Let's see what we can do. I have to have a total of 2 roots. What can I have? 0, 2, 0 seems great. Yeah, 2, 0, 0. That's definitely a possibility. Okay, we got a pair here for the irrational. Very good. 0, 0, 2. Yeah, that's good. 2 imaginary. That's fine. Anything else? Can I have 1, 1, 0? No, that's not allowed. 0, 1, 1? No, that's not allowed. 1, 0, 1? No, that's not allowed. None of these other ones are allowed. So that's it. Those are my possible combinations, just those 3. So now my question is, which situation is my graph? Which situation is this graph? We're going to go to Desmos, we're going to graph this, we're going to see what the answer is, which category we fit into, right? The 2 rational, but you know, well, let's just go take a look at the graph. X squared minus 6x plus 9. All right, x squared minus 6x plus 9. Go to our graph. X squared, oops, not x2. X squared plus 6x, no, minus 6x, right? Minus 6x plus 9. Oh, this is interesting. What have I got, everybody? It only touches one time. Whoops. It only touches one time. What is this? I'm not allowed to have 1 root. That wasn't in my list. I need 2. I need 2 roots, but this is only touching 1 time. What kind of root is this, everyone? We talked about this before. What is the name of this? Yes, thank you, Edward. This is a double root. This is a double root. So really there are 2 roots inside here in this one spot. Okay, so it's a double root. And looking at our category, we do touch, so it is real. And the number is a regular number. It's just 3. So it is a rational root. A real rational root, a double root. So it's 2 roots in 1. So if we go back to our chart, that 2 double roots. Come on, back to the chart. Which category is going to be the correct one? Which category is the correct one? Well, it's not imaginary, right? So it's not this one. They're not irrational. I think my answer is this. 2 rational, regular roots, but it's got a kind of special situation. It's a double root. And if I graph it, right, I notice it goes kind of like, touches it at 3. Two rational roots, a double rational root. Pretty cool. So that's what you're going to be doing. You're going to be looking at these equations, figuring out the combinations, the possible combinations with these charts, figure out these charts, and then looking at the graph and deciding which of these charts is the correct chart. Which one is correct? For your homework tonight, what I want you to do is make these charts for each equation. I want you to graph the equation that you see on Desmos. I want you to draw the graph. Draw the graph you see. Draw the graph. And I also want you to label the zeros. Like mine touched at 3, right? If I were to go back to this other one, my graph looked like this. And it touched at, what was it? It was like negative 1.447 and like 3.447, something like that. So label the graph, draw the graph, label the zeros that you have, so you can like have evidence for your choice. I chose this one because you see these numbers here, I think they're rational. That'll give me some evidence. Give me some evidence for your choice here. Label your graph. Draw the graph from Desmos and label the graph. So make the chart, draw the graph, label the graph. That'll be your assignment over the weekend. All right, everybody? Questions, concerns, worries? All right, let me write down what your homework is up over here. Homework is going to be 2.5, section 2.5. It's page 144. Numbers 5 through 8 all. And 9 through, what did I say? 9 through 27 odd. And then I think that was all for now. And then is that all? I think that's it. Yeah, I think that's it, everybody. Check on Schoology for this assignment. Do on next time we meet. I'll see you all later. Have a good weekend. Thanks very much. Goodbye, everybody.